Hello everyone, in this video I'll be explaining you the problem no 4 please, and it was asked in CodeChef starter 213. So let's read out the problem. An array B of length m is said to be good if no two elements from different indices sum to 4. That is, B is good if for every pair I comma j satisfying it is one based indexing of size m. That's why I is greater than equals to 1 less than j, and j is greater than I less than equals to m. We have bi plus ji not equals to 4. So you are given an integer, you are given an array a of length n such that all the elements are either 1, 2 or 3. So for each index I, and they're asking you would like to make a good array. To achieve this, you can repeatedly choose a single element of a and delete it. Got it. So what is the minimum number of deletions you need to make uh, a good array? So okay, we need to make array as a good array. So in that case we need to delete certain elements, and asking what is the minimum number of elements that you can delete. So let's understand the input format. We have test cases. For every test case we have integer n denoting the length of the array, and then for every you know in this, not every, in the second line we have n integers, uh, basically denoting the array elements, and it will either be 1, 2 or 3 as said here. So yeah, let's understand the test cases. They've given 4 test cases. In the first test case n is 3 and we have element as 1, 2, 2. So yeah, let's deal with this. It's good. So in the first test case we have 3 elements 1, 2, 2. In the question what they've said is you need to make array a as good. Okay, in order to do that, we will be deleting some elements. We will be deleting some elements which is basically a of I. Okay, and our aim is to delete minimum number of elements. That is our goal. So in the question what they've said is your array element will always be in the range 1 to 3. So basically array elements will be 1, 2 or 3. So only these 3 elements can be in our array, and this is one of the good observation. Based on this only I'll be telling you. So yeah, this is the given, and then one base indexing they've said. This is the question they've asked. So based on this observation only, one more thing they've said, in order to be a good array, so the element sum whatever you will be doing, right, this shouldn't be equals to 4, right? So that they're saying, and this should hold for every I comma j pair where your I is less than j and should be greater than equals to 1. It is one based indexing, and less than equals to n is basically size of the array. I think you have understood this. If you try to see here, you try to make a pair. So 1 plus 2 will be one pair, and one more pair will be 1 plus 2, and third pair will be 2 plus 2. Now you can't take this way, like you have taken 1 comma 2, so 1 plus 2, and then one more pair, it can be right 2 and 1 you are taking 2 plus 1. So both are same only, that's why it is a unique pair. So here if you see sum is 3, here also sum is 3, here sum is 4. So yeah, this is not a good array because we have one element wherein sum is 4. Two element sum wherein sum is 4. What if you try to delete this 2? If you try to delete this 2, your array will be and then sum will be 3, and it holds for every pair, right? We have only one pair, and this is true. What if I had deleted only 1? So in that case your array would look something this way, and still you have only one pair, but the sum is 4, and this is not a good array. So that's why now it is not a good array. Now one more thing you can do is delete one more 2. Now your array will be 2, and you are not having any pair which is not equals to 4. So this is also one of the value, but here you have done one deletion, and this is the second deletion, but in this case you have done only one deletion. So this is obviously optimal, right? We are deleting only 1. So in this example, your answer is 1. Yeah, for this example, answer is 1. So I'll not be explaining the examples, but let me go to the problem statement only. So since they've said you have only array element as 1, 2 and 3, so whatever array element you'll be having, it may happen that you may encounter 1 plus 1, right? Let's say you have this as array A as this. So now in this case you have all possible 1 plus 1 you have, 1 plus 2 also you have, 1 plus 3 also you have. Now if you try to do 1 plus 2, which is already done, again 1 plus already done. Now if you want to do 2 plus 1, which is taken care of this portion only, and 2 and 2 one more is there, so you can do this way. Okay, and 2 plus 3 also is possible. Now 3 plus 3 also is possible, right? 3 plus 3, so its sum is 2, its sum is 3, here it is 4, here it is 4, here it is 5, here it is 6. So now whatever array element you have, so this is the place wherein we should try to avoid this, because its sum is 4. So whenever you have 1 and 3 as the array element, you will get sum is 4, and 2 and 2 if you have sum is 4. So rest all is not needed. So let's focus on this 1 plus 3 and 2 plus 2. So in order to make this sum is 4, you will be having 1 plus 3. So what you can do is, see, now you try to delete 1, because 1 and 3 is there, so that's why I'm trying to delete 1. I've deleted 1, but still 1 and 3 is there, right? That will make sum to 4, so I'll delete one more 1. So now 1 plus 3 is not possible, so that's why this sum is avoided, right? Now one more thing we need to take care is 2 plus 2 sum. We have 2 and 2 one more. Let's say we had 3 times 2 in our original array. So 2 plus 2 is making 4. So let's try to delete one more 2. 1 2. So I've deleted. But still 2 2s are there, right? So still it is making sum as 4. That's why I'll be deleting this. So what our main idea is that whatever element you have 1 in 3, right? Let's say you had 1 1 1 as 3 times. So now in this case, if you remove all ones, you will be removing 3 elements. But what if you remove all twos, all threes? You will be removing only 2 elements, right? Here you are removing 3 elements, here you are removing 2 elements. This is the minimum, right? So that's why between 1 and 3, which is making sum is 4, try to reduce whichever is the minimum, eliminate whichever is the minimum. So in this case, if you see optimally, so we will be eliminating 3. So minimum count of 1 or 3, that will be eliminated. So if you eliminate either 1 or 3, then this is going to avoid. Now coming to 2 plus 2, no matter you have 10 times like this, right? Let's say 5 times you have, but your 2 in the array should be only 1 time. The reason being, if it is having, let's say, 2 times, it is making sum as 2 plus 2. 3 times also it is making 2 plus 2. That's why we need to take care of how many 2's are there, and if count of 2 is greater than 1, so all those elements had to be removed in order to avoid this 2 plus 2. So I think you have understood. So first step will be, basically we need to count frequencies of 1 2 and 3, and your answer will be, if this 2 count of 2 is greater than 1, so in that case it will be frequency of 2 minus 1, right? And this is like you're removing 2. Now we need to remove either 1 or 3, and your answer will be added with minimum of frequency of 1 comma frequency of 3. So this is going to give us our answer. So let's try to code it up. I think you guys have understood, so it's an easy only. So they have given test cases. For every test case we have integer n and the elements. So I've taken n size of the array. Now I'll take three variables 1, 2 and 3, and I'll run through a loop. I'll take one variable val because I'll be taking its value in val. If value is 1, then one frequency of 1 I'll be increasing. If it is 2, then 2, else it is 3. The reason being why I'm putting in else as 3, obviously we have only 3 elements, either 1, 2 or 3, that's why 1 and 2 I've taken care of this position, so 3 is obviously here. Now our answer will be, initially it is 0. We need to check if this 2 is greater than 1, which means the count of 2 in the array is greater than 1. So in that case, how many 2's will I have to remove? Actually only 1 2 has to be there in the array, so we should remove frequency of 2 minus 1. So these many 2's are there, okay, except 1 we'll have to remove all. Now once we have removed 2, so now it's time to remove either 1 or 3. So we have to remove the minimum number of 1s or 3. So that's why, and then we'll have to display the answer. Here it is getting passed. Let's try to submit in the online editor. Here it got accepted. So it was an easy problem only. Time complexity is linear, since we're iterating through array once, and we need to basically check the frequency of that. And this was one of the statement wherein you'll have to focus on, because it says how many different elements are there in the array. So yeah, if you had focused on this, you would have easily solved it. So thank you guys for watching the video.